Chapter number one, states of matter. This chapter can be done from the book. This is the easiest and most basic of chapters, but we're going to start with our notes, and really going to start with uh, definitions are a little bit random, so let's not go with the definitions first. We're going to start with states of matter. Now, we do understand that the three states of matter, in the terms of kinetic molecular theory or in the term of arrangement or movement or energy of particles, we can denote them with simple diagrams. Now, if you look at these diagrams, you'll notice something about solid. Solid are properly arranged, tightly packed, so much so every particle is touching the other. They don't have much space in between them, and if compared with a liquid, liquid particles are irregularly arranged. There is some space in them. They're not present in proper layers. They are loosely packed, and they have somewhat that amount of spaces that they can slide over one another. If we talk about gas particles, they're really far away from one another. They're irregularly arranged, very loosely packed, so much so they are far away from one another, and they are so distant from one another that this distance can cover a few particles in between two particles of the gas we're discussing. Now, they will be moving randomly, and they can move in any direction. They can be represented by the simple model above as small solid pairs. Gas particles have most energy. Particles are spread apart with random arrangement and random motion that I definitely would add to it. Now, moving on, liquid particles have more energy than those in a solid, but less than those in gas. These particles are closer together, they have a random arrangement, and they can slide past one another. This I would like to add to it, one and other. All right. And solid has least energy. Particles are not moving, they're only vibrating. Since they're not capable of changing their position, they're arranged regularly and very closely or tightly packed. Moving on, clarifying it up, we need to understand the interconversions between the three states of matter, how they're named, how they're achieved, the changes in arrangement or movement or energy of particles. Physical changes involve the forces between the particles of the substances uh, as interconversions, and these are not chemical changes. We do not form anything new, we simply change the state. For example, if we change the state from solid to liquid form, we call it melting, and the temperature at which it occurs is known as melting point. The reverse would be freezing. In this case, the liquid is converted back into solid, and again, this can be considered as freezing point. For most of the substances on the planet, melting and freezing occurs at the same temperature. However, there are a few exceptions to it. Next up is the conversion from liquid to gas. This is known as boiling. If that occurs at a specific temperature, that temperature is known as boiling point. The reverse or the opposite of that would be gas to liquid conversion, and that would be condensation. To be exact, uh, this is condensation. Condensation can occur at a slightly different temperature. Now, I would like to create a little bit of extra words to this explanation. Evaporation is also the conversion from gas to liquid, but this occurs at temperatures less than boiling point. So if that occurs at a specific temperature at the boiling point, only then it is known as boiling. Otherwise, it would be considered as evaporation. Condensation is the opposite of evaporation, and it occurs at the temperature less than the boiling point, of course. So when you change from solid to liquid to gas, the particles gain more kinetic energy, they move around more, and they become more randomly arranged. Of course, further apart as well. When you change from gas to liquid or to solid, the particles lose kinetic energy. They move less, become more regularly arranged, and closer together. Okay. When you do this, you require heat, and when you do this, you remove heat from the substance. Okay. So moving on, we need to understand how the result of experiments involving the dilution of colored solutions and diffusion of gases can be explained. So diffusion is the movement of particles from an area of higher concentration to an area of lower concentration so that they are evenly spread throughout. This is the complete definition as per Edexcel. If you miss this last part, you get 1 mark less. So make sure you explain the area of higher to lower concentration. Make sure you explain movement of particles till they are evenly spread throughout. That's how you get complete 2 marks for this definition if this definition comes as a question. Now for this to work, particles must be able to move. Therefore, distribution does not occur in solid. And since particles can move a little less in liquids, this occurs in a limited amount of liquids. However, this occurs really easily in gases. Colored solutions are diluted by adding water. Particles of color diffuse to the air of lower concentration, mixing with the water molecules, causing dilution to occur. Dilution is actually addition of water to a substance to a solution. The more water you are going to add, the more diluted it becomes. Now we need to understand a few terms over here. For example, solvent, the liquid in which solute dissolves. Solute is usually the substance which is dissolved in a liquid to form a solution. Solution is a mixture of solute and solvent. Solute dissolved in solvent. Saturated solution is a solution in which no more solvent can be dissolved at a specific temperature. So these definitions are shortened so much that if you don't write these specific things, you're not going to get complete marks in Excel. So make sure you mention these small parts that I'm adding to these notes. Okay, moving on. This is for chemistry only as it states. Knowing what is meant by the term solubility in units, grams per 100 grams of solvent. Solubility is grams of solute that will dissolve in 100 grams of solvent. Again, at a specific temperature. Okay, so understand and how to plot and interpret solubility curves. Solubility of solids generally increase when temperature increases. Um, Usually or generally are safe words like here, we need to put them because there are solids in the world for which the increase in temperature, the solubility does not increase. There are some solids in the world for which increase in temperature, the solubility instead of increasing actually decreases. So usually, sometimes, most of the times, rarely, frequently, are the words that are known as safe words. Putting those words right in there makes the examiner understand the fact that the student knows there may be some exceptions to this rule. And chemistry is full of exceptions. So safe words like these actually make sure that you get your marks properly. So that's why I'm adding the word. Solubility of gases usually or generally, most of the time, increases when the temperature increases or temperature decreases. Okay. Any mass below the line for a solute at a specific temperature would mean the solid solution is unsaturated. Any mass above the line for solute at a specific temperature would mean the solution was supersaturated and unstable. Supersaturated solutions made at higher temperatures are supersaturated solutions. Okay, so these is about the lines in the graphs. Let's see if we have a graph next. We can easily explain about the stuff about these lines. So the practical is to investigate the solubility of water at a specific temperature, get back to the book so that the points that we are left with, we can explain those points. So we have almost the same diagrams and the same explanations for kinetic model of matter, heat going in or being given out in melting or freezing, okay, or for boiling or condensation or evaporation or sublimation deposition, which note left, which are important since we convert solid directly into gas or gas directly back into solid without going into the liquid phase. So sublimation and its opposite, deposition. Sometimes the opposite is also named as desublimation, or sometimes we even use the word sublimation again. That's fine if we use the word sublimation or desublimation or deposition. All three words are acceptable and you actually get marks for any of these. Now, there is something that the notes did not cover, and that is actually really important and have been a part of past papers, is working out the physical state of a substance at a particular temperature. Now, if the temperature is given and the melting and boiling point of that substance is given, it should be easier for you to see whether that substance is going to be a solid or a liquid or a gas at a particular temperature. Let's say we're talking about oxygen. The two pieces of information in the question would definitely be given: the melting point, which is specified over here, and the boiling point. This would be part of the paper, a part of the question in the paper. Now, let's assume that the question asks you to find its state of matter at room temperature. So this is the room temperature. Since this temperature is lower than the particular temperature given in the question, it's going to be a gas. So if something is higher than that, it's going to be a solid. And if the room temperature falls between the melting point and the boiling point in such a way that it's lower than the boiling point but higher than the melting point, that specific thing is going to be a liquid at room temperature. This acts like a certain set of formulae. So I'm going to use the same term, particular temperature. So let's assume that particular temperature is PT. So if the PT is greater than melting point or boiling point, it's a gas. This is the formula for gas. If you need to talk about the formula for liquid, then the PT should be right in between boiling point and melting point. Means particular temperature should be lower than the boiling point and greater than the melting point. Like in this case, boiling point is somewhere near 60, melting point is somewhere near -10. So the particular room temperature 25 is right in between both. It's a liquid. Finally, for solid, the formula is going to be pretty easy. That is, PT is actually smaller than the melting point or the boiling point. Actually, both, to be honest. Then it would be a solid. So that's how we actually explain or formulate for all three of these. I hope that's clear. Let's clear it up. Let's move forward. We've already discussed
Yes, sir.
diffusion and how the particles spread or the simpler experiments. This is also a great experiment to show how the white ring forms in a reaction between ammonia and hydrogen fluoride form NH4Cl. And actually, it's not in the exact center, and it's somewhat closer to HCl, and it's actually somewhat farther from NH3. Automatically you are going to assume this is a lighter gas and this is a heavier gas, and this will give you more deduction. Lighter gas travels faster, right? And heavier gas travels slower. And how do you know that something is traveling faster or slower? It's pretty easy. If it covers less distance, it's probably is traveling slower. If it covers more distance, it probably is traveling faster. So it's pretty easy. Lighter gas travel or diffuse faster, heavy gases travel or diffuse slower. So if I cut out the word travel and convert it with diffuse, it would be then the exact chemistry I need to talk about. So diffuse faster, lighter gases, heavy gases, diffuse slower. So if a diagram like this is given in front of you and it's not in the exact center, it's pretty easy for you to pass a judgment about a gas. Whether you have seen the name of the gas or the formula of gas for the first time in your life, you don't know a thing about it. You can even then safely assume whether the gas was lighter or heavier. So this is something pretty easy to do. This is the dilution part, the solute solvent solution definitions, the solubilities, how we calculate the solubilities. Now, if I talk about the solubilities, this is the specific formula we need to understand. Mass of solute over mass of solvent into 100. Remember, 100 grams of solvent is always considered. Now, a solubility curve wasn't properly defined over there, so let me clear this up. Solubility curves are sometimes increasing curves. That means with the increase in temperature, the solubility would increase exponentially, and like that happens in this case, maybe the solubility increased really slowly, like happens in the case of KCl. Now, let me tell you, if you cool a saturated solution, you'll get some of the crystals settled at the bottom. We use the word crystallized out. For example, you started making a solution of KNO3, and I'm going to take the blue example, and you take the temperature all the way to 90. Now, 90, if extrapolated over here, tells us that we were able to, I know my lines are a little bit bad, but let's say we were able to dissolve up to 190 grams. What if we drop the temperature all the way to 30? Now, 30 is somewhere here. Let's say we were able to dissolve 40 grams at 30 degrees centigrade. This one is 30 degrees centigrade and this one is 90 degrees centigrade. So if you drop down the temperature, this amount 190 minus 40 is equal to 150 grams. This specific amount would crystallize out, which means it's going to settle down at the bottom of your container or beaker as undissolved solid. That's why we use the term crystallize out. And this kind of question is really easy. It's not very common in Excel. You're hardly going to see one or two questions like this. But since an example is given over here, you can always work out this amount. It's all about extrapolating on graph and finding out the value. Some of the values are given over here too. And questions like these actually make it easier for the student to understand the same facts that I've just explained. And this actually finishes the chapter. And this specific last part, you can see that they are talking about 19.8 grams of potassium chloride would crystallize out. Why? Because at two different temperatures, in this case, a higher value was dissolved, 51 grams. At a higher temperature, when we brought it down to 10 degrees centigrade, it was just 31.2 grams. So, of course, 19.8 grams are going to crystallize out, settle down at the bottom of the beaker in the form of undissolved solid, hence the term crystallize out. So this actually finishes up the topic for us. All right. Now, this diagram shows a kettle for us, actually, a kettle of boiling water, and we can see the kettle labeled water droplets, water vapors. As the water vapor cools, it turns into droplets of liquid water. The change of state when water vapor changes into liquid water is described as, now we need to see all the options. Boiling is liquid to gas, condensation is gas to liquid. Evaporation is, uh, my bad, this is liquid to gas. And sublimation is usually solid to gas. Now, we are converting a vapor into liquid. So this is gas, this is liquid. This is the only option that is true. Okay, this was pretty easy. Let's move to a more theoretical question where you need to form lines. Okay, describe what happens when water vapor cools to form liquid water. Your answer should include change in the energy, that means kinetic energy of the particles, the arrangement, and the movement of particles. Now, you need to understand this is the gaseous state and this is the liquid state as mentioned over there. So, from water vapors to liquid water conversion reduces the kinetic energy of the water particles. Okay, since this is just a one mark question, any explanation for the reduction or decrease in energy would be good enough. If you use the word reduce, if you use the word decrease, if you mention energy, or if you mention kinetic energy, that would be good enough. But mentioning any other thing rather than energy will not be a good way to write it. Arrangement. Now, water vapors are far away from one another in comparison to liquid water whose particles are closer together. Now you need to compare both the states and you need to tell them from which state are you converting into which state. So exactly what kind of arrangement would be converted into what another kind of arrangement. So gases far away from one another, liquids closer together. Okay. So the change in movement, vapors move randomly while liquid water particles can only slide past one another. Moving past one another, cover short distances, slide past one another. All these terms or phrases explain the same um, interaction of particles of liquid with one another. That's a very good way of saying it. Now, vapors move in a random motion over longer distances. So, any of those words are also correct to explain the same thing. Remember, you can use any terms or phrases which can explain the same idea. Now, a couple of different writing tips. If your writing font is bigger, then try writing in phrases instead of complete sentences so that you don't take any extra space. Well, I love at Excel when it comes to extra space. They usually give more space than what is required. There's always an extra of one line or two lines for every separate question or part question or subpart of it. So, what I love about them is that you almost never run out of space unless you are a stupid consumer of space. Stupid consumer includes too big of fonts, too much cutting and overwriting, indecisive way of writing. So try to avoid those. Decide first, write after. Do not cut or overwrite too much. If you're supposed to cut, a single line cut over a word should be good enough. This is good instead of doing this. This is not good. This actually messes the whole thing up. Okay? Try avoiding that, and single line cut should be good enough. Okay, and you can then keep on writing. Now, deciding first and forming a sentence is something that students are usually afraid of in terms of time. They think it takes too much time, consumes their time up, and it's better if they keep on writing and thinking at the same time, coming up with new words or sentences. Let me tell you, you might end up in cutting, overwriting, consuming more time than the person who was actually taking some time out to form the sentences. Yeah, at start, it may be taking more time, but once you get habitual with it, forming your sentences first and writing after is actually a pretty big savior of time. You just need to be good at it. I hope that explains a few of the writing techniques. We'll keep on explaining the tips or the writing techniques as we move on. Now, in chemistry, there are state symbols. S stands for solid, L stands for liquid, G stands for gas, AQ stands for aqueous solutions, solutions in water. They're often used. This table shows some changes of state. Complete the table to show the state symbol before and after the change. Now, instead of filling these up with words, like writing solid over here, this solid is definitely not the answer. I'm just giving an example. Is a stupid way of doing it. The state symbols are given right over here. Why can't we just write this? Okay. So try answering in the way the examiner is asking you to, so that you would know. So water boils in a kettle. Water is a liquid first and is converted into a gas after. Ethene is converted into polythene. Now, this is an organic example. I understand so far you haven't studied organic chemistry yet, so this is going to come as a problem. Don't worry. As soon as you're done with the last unit of the book, unit number 4, organic chemistry, you'd know that ethene is a gas and polythene is a solid. Okay. Moving on, crystals of iodine sublime on heating. We know sublimation is a conversion of solid to gas. It may be gas to solid, but since we're starting off with crystals, and crystals are solid, so it's correct to write this over here and this one over here. Okay, so moving on, the marble chips are added to solution of hydrochloric acid. Complete the equation for the reaction that occurs by writing the appropriate state symbols after each formula. So marble chips, solid. Solution means aqueous solution. Now, water is a liquid, right? I actually don't need this. And carbon dioxide is gas. Now, this one comes problematic. We all know calcium chloride is a salt, but who knows whether it's soluble or insoluble? Actually, to be honest, that is going to be a part of an organic chemistry. There is going to come a chapter in which you are going to discuss salts and their preparation and whether which salts are soluble and which ones are insoluble. After you're done with that big, huge table in the book, you'd know which salts are soluble and which ones aren't. Almost all chlorides are soluble except for a few, like silver chloride. So it's pretty easy to say that this one is soluble and will dissolve in water, forming a solution. Now, which state symbol is used most often for the elements of the periodic table at room temperature? That is solid. Why? Because most of the metals are solid at room temperature. And since metals cover 75% of the periodic table approximately, and all metals are solid, right? However, there is one exception, and that exception is mercury, the symbol for which is Hg, right? So, yeah, solid. Solid is the most used state symbol for elements at the periodic table. Now, you can always go to the periodic table and decide it, but if you know these simple facts, you won't have to move back and forth in the paper for looking at the periodic table. Since this is not the question where you need to go to the periodic table and look it up, this you can solve with simply the information you already have about the topic. Let's clear it all up. Let's move forward. Question number 3. This question is about the states of matter. Diagram shown are for three states of matter, solid, liquid, and gas. Each circle represents a molecule of the substance. Complete the diagram by drawing six circles to represent molecule and gas state. Now, these six circles are to be randomly arranged and far away from one another as much as possible. Okay. Number 2, which statement is correct about the movement or arrangement of molecules of this substance? They move randomly in the solid state, they move randomly in liquid state, they're arranged in fixed position in liquid state, they're arranged in fixed position in gaseous state. Now, just a second. The statement is correct about the movement or arrangement of the molecule. This substance. Okay, so they are not arranged in a fixed position in gas state. They don't move randomly in the solid state. They are not arranged in fixed position in liquid state either. They move randomly in liquid state. Okay, actually they slide past to move past one another in very short distances in liquid state. Since that is random, this is the closest correct statement that we can get to. Let's clear it all up. Move forward. Which term is used for solid changing into a liquid? That's pretty easy. Melting. So D is the correct answer over here. Clearing it up. Moving on to the next page. Some cold water is poured into a conical flask and a bung inserted. The diagram shows the flask after a few minutes. What is occurring in the flask? Okay. Boiling should occur at boiling point, and yes, along with it, condensation would occur too. But since it's cold water and we're not heating it up, so that's not the answer. Moving on, condensing and evaporating. Evaporation occurs at all temperatures. Remember this simple rule, and this is also mentioned in the first chapter. Evaporation occurs at all temperatures. No matter how slow or how fast, we all understand that evaporation is going to be faster at higher temperatures and evaporation is going to be slower at lower temperatures. But yeah, it keeps on occurring. That's how puddles dry up after rain. So yeah, the water would evaporate and form vapors. The vapors may condense back into the liquid. This might be the answer, but let's check out some other options. Evaporating and freezing. This definitely requires cooling. Since we're not cooling it, we can't say for sure that is true. Or freezing and melting. So freezing and melting do occur at a same temperature point, but that point has to be the melting or freezing point. But since that's not occurring, this is not the answer. By the way, for C, evaporating and freezing do not occur at the same time because when we are freezing, there is very less evaporation. This may occur in a few substances. Yeah, that's not impossible, but that's not true over the scenario here. So B is the correct answer. Moving on, which formula represents a substance that is not present in the flask? Okay, so that's pretty easy. D. Water is present in the form of vapor since it's evaporating. Water is present in the form of the liquid since we pour liquid water over there. Nitrogen is a gas that is a major part of air, so yeah, it is definitely present in this above portion over here. Nitrogen is not present in liquid form over there. Nitrogen is liquefied at a very low temperature, and since this is not at such a low temperature, D is the only answer. Remember, there is a big bold knot over here, so this is the one that is not present. Now, always be vigilant about bold words because they are written over there so that you don't make a mistake while reading this kind of sentences. Which brings us to question number 4. Now, when a liquid evaporates at room temperature, it changes into a gas. The diagram shows the arrangement of particles in a liquid. Liquid is being evaporating into a gas. Four particles of gas. Students tend to draw them in equal points, so please don't do that. It has to be irregular. So make sure that they are irregularly arranged. Describe the movement of particles. Gas particles move randomly and mostly over large distances, colliding one another. We can keep continuing writing about it, but even if you mention gas particles move randomly, collide with one another, collide with the walls of the container, or maybe lid of a container, is good enough. So moving randomly will get you the mark. Moving on, explain why heating a liquid causes it to evaporate more quickly. Now, this is a 2-mark question, and we are discussing why evaporation becomes faster when we increase the temperature and when we provide heat. So this requires at least 2 points in order to get 2 marks. So heating a liquid causes the intermolecular forces broken down or overcome, causing molecules to move away and evaporate, leave the surface liquid more easily and quickly. So if you're going to explain anything related to the similar meaning, even if you don't discuss about the intermolecular forces, even if you discuss that the molecules get more energy and then they're able to leave the surface of the liquid or get evaporated or converted into a vapor, any of those words are fine if you explain two separate points and how this affects. You may even discuss temperature as a factor of increasing the rate of evaporation, and that is also going to be correct for 2 marks. Remember, 2 points, 2 marks. Moving on. This diagram shows some pieces of apparatus that you may find in the lab. A is measuring cylinder, B is a filter funnel, C is, and I am pretty hopeful that we have these letters missing. C is a flask. We also call it a titration flask. D is a test tube. E is a dropping pipette or simple pipette. And F is simply a beaker. Now, moving on, you must be familiar with most of these. So, yeah, naming them shouldn't be difficult. I've already named them. Remember, B, filter funnel, D, test tube, E, pipette or dropping pipette, and F, beaker. Give the letters of two pieces of apparatus that could be used to measure an accurate volume of liquid. Now, this is something important. Now, let me tell you that beakers can contain more volume. This one and this one can contain more volume, but less accurate. How do we know it's less accurate? They're more wide, have more width. The more the width of the apparatus, the less accurate it's going to be. Now, this one and this one, they contain less volume, but they're more accurate. Why are they more accurate? Because as you can see, the less the width, the more accurate they are. Actually, to be honest, measuring cylinders comes as something right in between beakers and pipettes. They have a little bit of a width. They are usually accurate to moderately accurate, not very accurate, and they can even contain volume. So beakers may contain a larger volume, but not that. This is not graduated. Test tubes are usually not graduated. They don't have any markings on them. Neither is this one. So we can't really talk about them as uh, useful for measuring accurate volume. So this can be a measuring cylinder and a pipette. And you may also give the letters since this is going to be A and E. Okay. Moving on, question number 6. The compound with the formula H2O can exist in three states of matter. We're talking about water. The names of these three states are shown: ice, water, and steam. The numbers 1, 2, 3, 4 represent changes of state. So, which ones are these? You can write them. This one is melting. This one is freezing. This one may be boiling, or this one may be condensation. Now, the boiling might have been evaporation if we had the word vapors over here. Since this is steam, and steam is a term that we specifically used for boiling of water at specifically its boiling point. So that's why I have mentioned boiling and not evaporation. So you need to be capable of separating words and how or where they're used. So water vapors, yeah, you can go ahead and use evaporation since that's steam. Boiling is the right term to use. So part A, the particles of water are arranged differently in each state. In which state are the particles furthest apart? Of course, that is steam. In which state the particles have least energy? Ice. In which state are the particles arranged in a regular pattern? Ice. Moving on, change of state 1 is called, we've already named it as melting. So D is correct. Change of state 4 is called, this was condensing. So B is correct. The term sublimation is also used as change of state. That would be solid to gas, D. Heat energy, unfortunately, the letters for energy is missing. Heat energy is released when steam changes to water. What term is used to describe this type of energy change? Yeah, this is not a part of this chapter, but later on in other parts of the chapters book, you're going to see them, specifically physical chemistry. So this is exothermic. Whenever heat energy is released, that kind of energy change is known as exothermic. Now, moving on. Write an equation including state symbols for the change of state from steam to water. Remember, you always write the formulae. So steam to water, steam is gaseous, water is liquid, and this is the equation. If this is at equilibrium, which we're going to later study in the later part of the book, specifically unit number 3, we can show it with a reversible arrow. But for now, that is good enough for us. Okay, so moving on, the three states of matter: solid, liquid, and gas, melting, X, Y, and Z. So using the words X is what, X is boiling, Y is condensing, Z is freezing. So yeah, there you go. Which statement best describes the movement of particles in a gas? The particles vibrate about fixed position? No. The particles slide past one another? No. The particles move freely? Yes. C is correct. So C is your answer. Let's clear it up. Move forward. The diagram shows apparatus that can be used to measure the melting point of a solid. Name of apparatus labeled. Thermometer. Melts at 140. Why water is not a suitable liquid? Why? Because boiling point of pure water is 100 degrees centigrade. Is 100 degrees centigrade, which is less than melting point of solid Q 140 degrees centigrade, right? What can we use if we cannot use pure water? Let me tell you, anything below the substances that are below 100 degrees centigrade, right? So that is for those we use water. And if it's greater than 100 degrees centigrade, we use oil. Okay. So water is for anything less than 100 degrees centigrade. So that's why the liquid in the beaker needs to be stirred constantly for constant, and it's better not to write constant, instead consistent heating. That way, the melting point or the boiling point we are going to find is going to be accurate, right? This is a good way to do it. Okay, moving on. Number 8. Substances can be classified as elements, compounds, or mixtures. I don't really think this belongs to this chapter. So yeah, we can answer about this. The one on top is solid. The number 2 is a gas. This is pretty easy. Anyone can answer that. I don't think you're having a problem with these kind of questions. Okay, one something about diffusion finally. So the diagram shows ammonium chloride being heated in a test tube. Mixture A, white solid mixture B. How many different elements are there in ammonium chloride? Since there are three capital letters, so three different elements. Identify two gases in mixture A, that is going to be ammonia and hydrogen chloride, since that is same for what we have studied. Each gas named as one mark. White solid B, that is ammonium chloride. Again, because that sublimes. Or ammonia and hydrogen chloride can really react together to form ammonium chloride again. That's pretty easy. Okay, place crosses in two boxes to identify the processes that are occurring in the test tube. It's actually, wait, what? Um, yeah, it is decomposing, but since it's sublime, so neutralization, Yeah, that might come as a little bit tricky to you. It is decomposition. It's neither boiling or melting since it's sublimation. But yeah, neutralization is one of the answers. Why? Because ammonia is alkaline in nature. It acts as an alkali, and hydrogen fluoride is an acidic in nature whenever dissolved in water. So yeah, they are neutralized in forming a salt. So neutralization. Well, this doesn't really belong to this chapter. So that's about it. We have finished the whole exercise. Any questions?